All right. So good morning. Happy Monday. Today is the last class for this class for you. Maybe that's good news. Maybe that's bad news. But certainly, you won't have to wake up for this 9 o'clock class going forward. At least if you're taking my 216 class in the fall. But that being the case today, what we have planned is to complete our discussion on ensembles, and we will also go over um, some Jupyter Notebook for using ensembles, as well as correcting a few bits here and there for decision trees. And then we'll pivot to the last module. Hopefully I get through all of it, which is how to give an effective presentation. All right, so why don't we jump right in. Where we last left off, we talked about hide meeting controls. Oh yeah, the final exam is the 5th is a presentation, 10:30 to 12:30, and the final thing is due on the last day of finals, which is May 9th, the usual 11:59, 59 seconds. Any questions? No? Yes. Everybody I expect to be here. Yes. Any other questions? Yes. Mhm. Your presentation and acknowledging that you might not have everything done when you give the presentation. That's just part of the unfortunate reality that I don't get to choose the exam time. And so there are two strategies you can employ. One is to do more simple analyses all the way through. And then the conversation is what more complex analyses are you going to add? And the other is to do all of your complex analyses as far as you can get. And then the conversation there in your discussion is what remains to be done. And so, yes, it's not perfect, but just work as hard as you can, do as much as you can, and it's just presenting them to give you those that practice. Yes, Ryan. Yes, on the entire project. And so that fifth represents a snapshot in time of everything that you're doing. With an acknowledgement that you're probably not going to be done because you have 4 more days to work on it. Another question? Yep, sure. You can I only expect you to record the presentation once, right? You don't have to redo it to reflect what happened over those next 4 days, but the recorded presentation in on the 5th. Okay. All right. Any other questions? Yes. The recorded presentation is what you'd be presenting in class. And so I will be randomly picking from that, literally from a hat. And so the reason is we don't have enough time during the 2 hours to fit all the presentations. On the high side, if each person does their own project individually, that's 21 projects in 2 hours. Which is not possible to do. If on the low side, everyone has a group of two, that's like what 10 plus or minus 10 and a half projects, and so that also is hard to fit in the 2 hours. And so if everyone does one, then everyone will present. If everyone doubles up, then we can actually just squeeze 10 and a half projects in the 2 hours. Any other questions? No. All right. And then we had Ashley. All right. So why don't we get started? When we last left off, we talked about ensembles, and we said an ensemble is a type of, and I don't even think I mentioned this, a type of meta model. And this meta model takes a bunch of base classifiers. So ensembles are a classification method. There's absolutely ensemble regression, but we're not going to cover that in this class. And so with an ensemble, you have a team of M many classifiers, so-called component classifiers, and you train these on your in-sample data, your training set, and they estimate a final best hypothesis G, or in this case F hat, that will output a predicted label Y hat when you input a new example. And so the goal of an ensemble is to enterprise to improve the classification accuracy, this out of sample error, to drive it to zero as much as possible by combining votes or the quote unquote label estimates or predictions from each one of the component classifiers in your ensemble. And so this idea of improving outcomes when you combine estimates goes back to the late 18th century. Said that right, the late 18th century, with the Condorcet jury theorem, which is from political science. And with this, we modeled the error of the entire group, going from the majority error, bless you, to the overwhelming error, assuming jurors are so-called competent. And so with this, we showed that with an error rate for a particular component classifier or juror of 20%, with just a small group of three combining their estimates by voting, you can reduce the error of the group relative to the best of the components, 20%, by half. So error rate goes down from 20% to just over 10%. All right, any questions? Does that make sense? And so in human populations, oh, forgot about this graph. I was a little clumsy when I talked about this graph. There's a second graph for this. I looked back over my PhD thesis. You kind of forget things over time. But this particular graph represents the non-majority error. If we have n or m many component classifiers in the ensemble, you can tolerate floor of n over 2 many errors, right? And if it's even, you just say make it odd and call it a day. And so that being the case, I've plotted along the horizontal axis the size of the ensemble, and on the vertical axis the probability of error. And right where you see 12, you sort of project up, you get 95% non-majority error. So that means with an ensemble size or a jury of size 12, if the non-majority error has a 95% probability with an ensemble size of 10, that means non-majority error. That means that the ensemble is still correct, right? Does that make sense? All right, so I apologize for that flub. All right, so we talked about what happens when you're doing jury selection in human trials. In order for this jury to be incorrect relative to ground truth, they have to share biases. And it's the goal of the prosecution and the defense when you're selecting jurors from the public in your particular county. If you've ever done jury duty, it's interesting. They try to bias this decision, the jury, their outcome or their voting power, so to speak, by exploiting what they deem are common biases. And so for human populations, they might try to game the jury by having more representation or less representation of various human demographics. And the similar idea goes for our ensemble or classifier jury. If you want this jury to be correct, then you want to assemble them, the component classifiers, in a way that you break any possible sources of shared biases. Okay, any questions? Does that make sense? Jar your memory. Friday seemed like such a long time ago. All right, and so popular approaches for doing this, we'll talk about boosting and bagging, and then we'll end with random forest, and you'll see an example in the Jupyter Notebook. And so the aspects of a learner, in particular, a classifier, so we're talking about supervised learning for ensembles in this case, you can vary the instance selection and various other things that go into the anatomy of a learner. And so when you talk about the instance selection, we've been talking in this class up to this point about giving all of the training inputs to your classifier, to your learner. But that doesn't have to be the case. You can have a set or a team of component classifiers, and each one gets some subset. And the approach in the common approaches, or the most popular approaches, is to randomize that selection from your training set, your training input, your in-sample points. And so there are two ways of using randomization to break these shared biases, also known as error diversity. You want them to commit errors in different parts of feature space. One is by sampling, and the method and variants of the main method called bagging, they sample the instances, the input, the in-sample training data. And then the other is by directed sampling or biasing. And it's called AdaBoost. And with this, you change the distribution that is responsible for selecting the training inputs. And so if you change this distribution using a series of weights from one sampling to the next, you're going to focus on different examples from feature space and therefore focus on different regions of the inputs of feature space. Does that make sense? Any questions? Yeah. All right. And so bagging was done in 96. It's an oldie but goodie by Leo Bryman, who was at Stanford. He passed away, I think, like 15 years ago. And with bagging, also more long known as bootstrap aggregation, bootstrap as in bootstrap sampling, it's based on the idea that your component classifier is so-called unstable. And what unstable means is that if you change the selection of your training inputs, your errors are going to change for your classifier. And so let's draw on the board here. And let's imagine you have a two-dimensional feature space. We have the X1 axis and we have the X2 axis. And like we said before, right, with our classification example, imagine if we have two classes. Let's call this group 1 and let's call this group 2. Now, if we have a high overlap, there are examples that belong, let's call these negative examples, that belong to group 1, but their feature values match the features, are very close to the feature values of things that ground truth belong in group 2. And so we called this overlap region the confusion, no spell check on the chalkboard, the confusion region. And that means that any classifier that you train or fit to this data is going to get confused. Because here we see an example. This example, right? It's a negative example, ground truth. It belongs to group 1. And this example, right next to it in feature space, very similar values for its features, belongs to group 2. And so if you were to take a classifier, and I'll just draw a dashed line to represent something almost like a perceptron. And if you change the selection of instances, this, when you train, is going to move differently if you have one subset of these for training versus another. Does that make sense? So by biasing or changing the distribution so that different subsets of your in-sample data get input into your classifier when you're training, you're going to get different errors. And that's error diversity. And the goal in breaking these shared biases is to try to make the errors diverse. Okay. Any questions? Yeah. And so in bootstrap aggregation or Bryman's bagging, this instability is an assumption for your classifier. So it's an axiom, has to be true. And you start out with what's called a replicate. So uniform at random with replacement, you're going to subsample your training set, producing a so-called replicate. And each one of the many component classifiers in your ensemble inputs one of these replicates, and then you run your learning algorithm. When that learning algorithm halts, you're going to get a different version with different errors of our final best hypothesis, G, F hat in this case, and then you aggregate their label predictions you with a uniform vote. So this is a fair voting scheme. Each classifier gets one vote to say, I think the label should be +1. I think the label should be -1. Each classifier gets a vote, and you take the majority class label from these votes. Does that make sense? Any questions? And so what we'll see in the Jupyter Notebook, when I bring that up after this module, we'll see that one of the prerequisites for using the API for bagging classifiers, you have to tell it what type the component classifier is. Does that make sense? All right. So boosting is that other approach. And boosting, Eta boost in particular, which is the most popular algorithm, was done by Freund and Shapiri. Also, no, that wasn't in 96. I think that was 95 or 94, maybe. I'd have to look that up. I'm not confident about that date. But what boosting starts out with, here we have depicted along the horizontal axis, we have each one of our inputs. So if you have n many training inputs, let me wake up the pen. We'll do blue this time. You'll notice here there's a weight, and there's a weight associated with each training input. And so each training input starts out with an associated weight, the so-called boosting weight. And these weights in the beginning, if you have n many training examples, you have n many weights. Now, I just depicted them as a bar chart just because I need to visualize them somehow. I like pictorial visualizations. Now, you'll notice here the weights initially are the same amount, right? So it doesn't matter what those values are. Could be 1, could be 10, could be 1,000. That forms a distribution. If you take each one of these weights and you divide it by the sum of all of the n many weights, that's exactly a uniform probability distribution. And so with this, in the first round of boosting, it's going to, with a bias or probabilities specified by the set of weights, it's going to use that as the criteria for selecting each one of those training examples. So this means it's uniform at random without replacement. Each one of these training inputs from our original training set has an equal chance of being selected for some sample. Now, of course, the sample can be a size n, could be a size 2n. It doesn't matter what it is. What matters is that you start out with the opportunity to have equal representation among all the training inputs across your in-sample data. So now you train your classifier by producing a replicate, and this replicate is a sampling uniform with replacement over all of your training inputs. Now, the only reason it's uniform is because these weights are all the same. So you use that replicate from this initial set of weights, that initial distribution, and you train a classifier. Now, when you train a classifier, we know at this juncture, on your training set, you're going to get some places where the classifier agrees with our ground truth label, and some places, on some instances or inputs or data points, where it disagrees. And those places where it disagrees, it's in error. So it commits an error on some of these. Now, what you do in boosting, then, for all of these inputs in sample data in the replicate where it had an error, you're going to increase or quote unquote boost the weight. And so what these error instances are also called the so-called difficult instances. And you'll notice here, when you're in this confusion region, that's where the difficult instances are, right? And so I've drawn a two-way overlap, but you can have an arbitrary way overlap depending on the number of natural groupings that you have in your data. And so what ends up happening is that this distribution changes with a bias now, a preference, an increased weight that's going to select more and more for the so-called difficult instances. And so you have one error for this version of the classifier. And let's imagine the difficult instances were such that you had a different classifier that was trained because it's a different subset of these in-sample points with a preference for the so-called difficult instances. Now, if the next classifier trained is going to have a preference for selecting these difficult instances, absolutely its errors are going to be different from the first one. Does that make sense? Any questions? No? All right. And so you do this and produce a new replicate, focusing more intently on the difficult instances. And then you do that many times, each time boosting the difficult instances in your quote unquote boosting sequence, which resulted from the bias on these input weights, changing the distribution so that subsequent classifiers trained in the boosting sequence focus more and more on the more difficult instances. So the errors will be different. Does that make sense? Any questions? And so here, boosting implements a schedule that says, I'm going to force you to make your errors different, i.e. error diversity, by focusing more intently on the difficult instances in this boosting sequence. Okay. And so it's based on this rigorous theory called the weak equivalence theorem. The paper was written, it's a theoretical paper in 1990 by Freud and Jupyter, and it really beautifully outlines why this works, and it does work. All right. Any questions? No? And so with boosting, it's not fair voting. Your vote is based on how correct you are. And this vote takes the log odds ratio for the error rate versus how correct it is. And so minus log is the same as log of on error rate over error rate. And so what this does, it says, I'm going to take the log odds ratio between how correct you were divided by how incorrect you were, right? Your correctness rate over your error rate. And whatever that proportion is, that's the weight for your vote that you get. So those classifiers that are more correct are the ones that get a bigger say in what that label should be. Does that make sense? Any questions? So it's non-fair voting in boosting, but it's fair voting in bagging. Okay. And so there are other techniques that are related that focus both on the instance selection as well as the feature representation. And so imagine if you had a feature set that was like maybe 100 features. So you have a 100 dimensional points in feature space. Random forest. Now, random forest is specific to decision trees. What is a forest? It's a collection of trees, right? So they had a really cute naming for it. But like bagging, with random forest, you're going to sample. We know that bagging samples each one of the training instances to produce a replicate, but random forest is a little bit different. Not only do you sample the training inputs, you also sample the features. And so if you have a feature vector x1 hat, x2 hat, all the way through x100 hat, you're going to sample some subset of the features. So you're choosing different representation in addition to the instances. And we said when you transform your feature space representation, one of the things you do is you change the geometry of your feature space. And so one example to kind of illustrate that to you, I'm going to draw an axis. Here's x1 hat, here's x2 hat. And let's imagine all of your negative examples were clustered around here, kind of bunched around. And let's say all your positive examples, group 2, were clustered around there, further away. Now, of course, there's no way you can draw a line on the plane to separate the positive instances well from the negative instances. The geometry just doesn't afford that. But if you transform this representation with a polar transform, right? You take the distance, square root of the distance along x1 and x2, or you could just square them for each one of these points. And what does that give you? Okay, it gives you a different geometry. So all those points that are closer to the origin, if you square the x1 component and the x2 component, they're going to be closer to origin in the transformed version. And all of the positive points, they're further along the x1 hat and x2 hat axis. If you square those features, they're going to be further away from origin. Now with this transformation, the geometry is such that you can separate them with a line on the plane. And so this idea of changing the features through some transformation, and in this case, random forest does it by selecting them, you're changing the geometry, and there is a geometry out there in a transformation that will make it easier to separate the points with a more simple class of functions for your hypothesis set. Does that make sense? Any questions? Okay, if you take a more theoretically oriented machine learning course, they'll talk about something called kernels, which is a particular type of transformations that's guaranteed to make things so-called linearly separable. Okay, does that make sense? No? All right. So this is our random forest. You sample the data set to produce a replicate, but these replicates, you're also sampling from the features, changing your representation, and then you're building a decision tree. Now, for bagging and boosting, you have to use a classifier. You can use any classifier, not just decision trees, but random forest specifically is decision tree. Does that make sense? All right. So that's all I had. Let's pivot to the Jupyter Notebook, and I'll show you some examples of some trees from scikit-learn. So let me share screen. PowerPoint always messes with the share. So I'm going to exit the PowerPoint. And I'm going to redo the share, which is the only way to guarantee that it doesn't do wonky things. All right, so where is Safari? There we go. All right, so I have up a Jupyter Notebook. And with this notebook, it's very similar to what we had covered before, but I'm going to focus just on the two types of classification problems. We have the grouping of 2, for our in-sample data, and we've relabeled it based on a grouping of 4, right? So the only difference here is I've included, you'll notice here, in addition to tree, I've imported the AdaBoost classifier, the bagging classifier, and the random forest classifier. So I'm going to bump down but I'm not going to talk about the stuff we've talked about before. We do have the grouping of two, and it's the same mortgage application data where we had two features, annual salary and years in residence. And I, in this example, had run a decision tree, a single decision tree on that two-way classification and showed you this tree was very simple. And then I created a grouping of four, a four-way grouping using clustering. And then I labeled those groups 1 through 4, and then used that as a decision problem to try to classify with a single decision tree. So I construct the labels and I create the data frames, assigning a target label based on those groupings. And now here, I train a decision tree classifier. And of course, I can plot out that decision tree. And you notice that decision tree is a lot more complex because the problem is more complex. You notice on this four-way grouping, I have some overlap. I have some confusion regions, some areas at the seams between two adjacent groups where they're very close to one another. And in some places, they overlap along the horizontal axis. Does that make sense? Any questions? No? All right. So we've seen this before. Let me figure out where my cursor is. Decision tree. So now, this was something I wanted to correct. Before I said EN is equal to the training score and the testing score. All right, that's the accuracy. That's not the error. To compute the error, you just take the floating point 1.0 minus the accuracy, right? So I correct that here. And I also have this particular Jupyter Notebook posted alongside the slides for today, module lecture 28. Does that make sense? So we see that EN is 0 and E out is about 2.5%. So they kind of are close to one another. Okay, well, that's a good thing. Now here is our ensemble methods. Now here I've included in this comment block some URLs to scikit-learn standard documentation, and I'm constructing 3 different ensembles. One is random forest, and I say make a random forest consisting of 2 trees. A random forest assumes trees. And then I have a bagging classifier with 2 classifiers and a boosting classifier. Now here you'll notice I'm specifying for bagging and boosting the number of estimators, the number of component classifiers is equal to 2. If you don't specify the type of classifier, it defaults to decision trees. Does that make sense? And so in the documentation, I think it's called, I can't remember the keyword. I think it's model or estimator type or estimator or something like that. You can look at it in documentation. You can specify all sorts of classifier types, not just decision trees. But if you don't specify one, the default is decision tree classifier for bagging and boosting. Does that make sense? All right. So we're going to build 3 ensembles, a random forest, bagging decision trees, and boosted decision trees. And we go ahead and we do that. And so now we're going to do our predictions, setting aside, I think it was 10% or 20% of my data for testing. Let me see, train test split was, yeah, 20%. So I'm setting aside 20% to estimate out of sample error. And let's see, there. And then I go ahead and I train it and I compute the accuracy for in sample as well as the accuracy for out of sample. And so here I do the prediction on the training set and testing set for random forest, do the same thing for boosting. I do the same thing rather for boosting, and then bagging is above here. And then I compute the accuracy, and then I go ahead and compute, oh, that's not E. Let me just change this. That's not accuracy. Accuracy. Let me just ACC, 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 ACC. All right, just to be absolutely correct. All right, so I go ahead and I do that, and we notice for the out of sample accuracy, random forest is about 22%. For bagging, it's about 7%. For boosting, it's 32% accuracy, which isn't very good, okay? So let's bump up the size of the ensemble. Let's make them each ensembles of 10 classifiers, and we'll rerun that. and see how that does. So now we do that. Random forest is 5%, so it didn't really improve. But we see that bagging is 5%, boosting out of sample is 32%. Okay. So let's try to bump that up to, I don't know, 25 predictors in the ensemble. And let's go ahead there, go ahead there. We see that boosting got a little smaller. The out of sample accuracy is about 17%. Bagging was 2.5. Random forest got even a little bit better from 5% to 2.5%. The, oh, did I do that right? Training score. No, no, no. Oh, gosh. Why am I? That's right. EN is 1 minus the accuracy. I just got that backwards. Oh, goodness. Um, uh, I was right the first time. Okay, so let's try that again. Yeah. So we start out with two ensembles and two ensembles, and we go ahead and we see our error. Out of sample error is 22% for random forest. Out of sample error for bagging is 7%. Out of sample for boosting is 32. So let me just get to the punchline and just try ensembles of size 20. And you'll notice it went down a little bit, not very much. But if we increase it even further, at some point, the ensemble size will give you dramatic reductions. You get diminishing returns, and it kind of peters out. Now, one of the issues with this data set, going back to what it looks like as a point cloud in feature space, it is a little bit of confusion, but there's not that much. If you'll notice here, with a straight line, you do pretty well separating the green cloud from the blue cloud. The blue cloud from purple, you might get 2 points that are in the confused area. And then the red cloud from the purple cloud, you might get a handful of points. And so this point cloud is not very confused. It's not deeply confused. And where ensembles really benefit you is where you have a relatively large confusion region in feature space. Does that make sense? All right. Any questions? Yes. How it works? ADA Boost, you have a non-uniform vote based on the accuracy. And so you have, as we had in these slides, a boosting sequence. And that boosting sequence changes the the bias of how you select instances. And so on one round of boosting, you have one classifier that has all the instances selected uniformly. And then depending on where the errors for this one occurred, it's going to, with the next classifier it trains, prefer those more confused instances, right? So it's going to literally choose a different classifier because it's going to select new training instances. And so for boosting, it's a non-uniform vote of the individual classifiers. For bagging, it's a uniform vote. And for decision trees, it's a uniform vote. But with decision trees, you induce error diversity by sampling both the instances as well as the feature space. And so this demonstration was an example of what changing the feature space can do. When you change the geometry of the representation, you're going to change where your classifier commits errors or the instances on which it commits errors. Question? It might be. Mhm. It does in a sense use gradients, and in fact, the statistics department has a beautiful paper. I can't remember who wrote it. That it's saying it's doing projection, right? So when you think about gradient, a gradient is just a projection onto a set of orthogonal axes, and you're walking down in some direction. And so AdaBoost is doing that. But I can post the paper to the Slack channel that talks about that. There are a lot of boosting based variants that do all sorts of stuff because in essence, you are solving an optimization problem with AdaBoost. Only they're not using it for mathematical optimization. They're using it for generating a classifier. Okay. Any other questions? Make sense? Okay. So in the time that remains, let me stop the share and let me go to the segment on giving an effective presentation. So I was hoping this would be fun. All right. So we'll see how it goes. Um, So let's see, it's 27, 28. There we go. And let me share, maximize to the slideshow. And let me, oh, I hate that. You're seeing that on the screen, but I've had it before do weird things because I see like two different things on my screen. So let me just minimize that. Let me get rid of that one. All right. Okay. So where's my other one for PowerPoint? File, recent 28. My screen looks very different, and what's on my screen is reflected on the recording. So I've had this issue happen before. Okay, slideshow. And where is my slideshow? Okay, where's the clicker? All right, there we go. All right. Hide floating meeting controls. And hopefully that is okay. All right. So all that remains is the final exam. And today I'll sort of talk about some pointers for giving an effective presentation. And so in order to do that, I'll start with an introduction, and then I'll get into the goal of communication, and I'll get into something called the symbol grounding problem. It's something from perception. I'll then walk you through the meaning of the word suck, because I want to make sure that everyone has the rated G version and not other versions of what that word means from colloquial American English. I'll also talk about this idea of the mind's eye, and then give some examples of ways to make your presentation suck, as well as some ways to make your presentation not suck. So what I just did, talk about this next slide. The whole goal of communication is to cause a sequence of thoughts in the minds of your reader. And what I just did here, I absolutely hate. Right? A lot of times, people, when they give a presentation, they'll start beautiful first slide, and then they'll have effectively a table of contents and then explain to the audience all the things that they're going to talk about. The reason why doing that is particularly bad is that when you are giving a talk at the outset, that first 30 to 60 seconds is very critical. During that first 30 to 60 seconds, you're either going to commit your audience and they'll consider to invest their attention into what you have to say, or you'll completely lose your audience. So when you give this notional table of contents, you're kind of wasting that floor time, that 30 to 60 seconds, and losing your audience. You want to jump right in to pictures, engage in something that the psychologists call shaping. Right? If you've ever seen a horse and buggy in Dover, Delaware, where I used to live, in the western edge of the city, is the second largest Amish settlement in the country. So they ride horses and buggies. They kind of do things old school. And one of the things you see when they're riding along in their horses along the street, you see these big blinders on their heads. And that's to keep their attention in a particular area. And so what you want to do with shaping is you want to limit the attention span, because minds can wander, right? Everyone has a finite attention span, and you want to spend that very wisely. So what I like to do, and what was recommended to me, hopefully it's helpful to you, is I always start my presentations with just a picture or something very, very simple, because you see the picture and I provide, or you as a speaker provide the narrative for that picture. And so that does two things. They're looking at a picture, and most of your brain matter is devoted to visual processing, and they're listening to what you have to say. So you've captured their attention span. So let's try this again in another way. Effectively, what you're doing at the outset is giving your audience the trailer for what it is you're trying to say. Okay. So communication throughout the ages has been used to do all sorts of amazing stuff. In the case of Dr. King, mobilized an entire nation. Communication can also be used to highlight something that's really, really important. Here we have so-called Mass and Cass in Boston. It's an intersection of two major streets. And this is a blaring example of the conspiring of homelessness, mental illness, and drug addiction. And it makes you wonder, in such a wealthy state, in such a wealthy nation in the capital city, how does this happen? Right? And so the goal of communication then is to move you, to cause a sequence of ideas to arise in the minds of your audience. So let me ask you, I'll kind of step out of the presentation. Which one caught your attention more? The table of contents or the shaping version? Or none of them? Yeah. Uh-huh. 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 Mm-hmm. Ah, yes. But I, as someone trying to impart ideas to you, you have one set of attention span. You're spending some of it on reading. Oh, what's this going to be? And then you're spending some of it on the picture. And then you have to spend some of it on what the speaker's saying. So if I kind of turn off that part of your brain that reads words and goes back to the semantic meaning of what those words are, now I've forced you to kind of narrow your focus and spend more of your attention span on the things I want you to walk away with, not on the stuff that your mind is going to kind of wander off with. So it's a very specific thing, but it doesn't come for free, right? You have to spend a lot of time, invest a lot of time in really good pictures. And for every presentation I make, I spend a lot of time on my pictures. The good news is if you present things a lot, well, you can reuse these pictures and tweak them and, evolve them over time. And so this idea of a trailer, you get the introduction, but you really want to control the thoughts, not in an evil way, but the sequence of thoughts that you want your audience to walk away with. Does that make sense? So yes, absolutely. People will read it, but the more they're reading, the less they're attending to those ideas you want your audience to have. Okay? All right. Any questions? No? All right. So I do this floating table of contents because, like you said, you can read. And I don't need to spend the first 30 to 60 seconds wasting your attention. Because if I just start the table of contents is this, and I'm going to talk about that, and then I talk about it, why not tell you while I'm doing it where this is going? So I can focus on the story and not on sort of all these meta information describing things about the story. Because the best way to impart a story is to tell the story, right? Not to tell things about the story. Does that make sense? All right. So the goal of communication has to do with the symbol grounding. So I'm going to walk you through an exercise, right? If you want to, you don't have to participate. If you close your eyes and you imagine the following: nice, fuzzy, cute, and warm. Okay, let's open your eyes. Did you imagine something like this? Little fuzzy puppy. Now, it might not have been the same thing for you. Maybe it was your favorite warm blanket. Maybe it was when you were a kid and you visited your grandparents. It could have been all sorts of things. Now, the thing that makes the symbol grounding problem an interesting concept when it comes to communication is that everybody brings to bear the realization in your mind, your so-called mind's eye, what the picture is associated with words. Now, because we all come from different experiences, backgrounds, and all these things, each person is going to have a different picture in their mind's eye. So the hard part about communication is to get it right with your descriptions and your visuals, because you're trying to cause thoughts in the minds of your audience. You want to be careful about the picture you're causing them to paint in their mind's eye. Does that make sense? Any questions? All right. So if I said the words warm, savory, comfort food, right? Everybody's thinking of something different. What's some of your favorite kind of, when you're a kid, warm, savory, comfort food? Anyone have a favorite? No? Maybe some it's pasta. Maybe some it's something else. I'm sorry, mac and cheese. Mac and cheese is good. My wife makes a great mac and cheese. I do the barbecue. I don't do the oven stuff. Casserole. Yeah. Anyone else? No? All right. So I think of this one. Zoppa di pesce fra diavolo. A friend of mine who was Italian introduced me to this, and oh my gosh, it's amazing. It's like a seafood stew. But nonetheless, another visual. It's different for each person. It doesn't make what's wrong and what's right. It's just different. So if I said comfort food in my presentation, you'd immediately be thinking something else, not peanut butter and jelly sandwich. Maybe PB&J is comfort food for somebody, right? But it's not for everybody. Now, if I said a warm summer's evening, maybe you get a picture like this. Now you notice I'm not using any words on my slides. I'm giving you a concept and I'm deliberately trying to get you to experience the idea of symbol grounding. And that's another technique that you can use. If you remember, if you see it and you read it, you're going to forget it. You're going to forget about 60 to 70% of everything you read. But if you experience something, you experience symbol grounding, you'll never forget it. So asking the audience to participate or some finding a way to get them to experience what you're talking about is a much more powerful way to get your audience to engage, capture their attention. Now, I didn't know this out of the gate. I had no clue about any of this as an undergrad. I had to learn this in industry, and I learned it in grad school, more so in industry. Okay, any questions? No? And so, in order to make sure we all know what we're talking about, we want to go over, in this case, the meaning of the word suck that I intend. And I purposefully choose that word because it has many colloquial meanings, some that are rated G and some that are not rated G. And so one of the things to do is establish what you mean in your presentations, because again, everyone has finite attention span. And if I gave the same talk in a middle school or high school, everyone would be giggling and laughing and be like, oh, what's he talking about? Ha 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 ha, because I let their minds wander, right? And so this is part of that shaping thing that I talked about. After letting somebody experience something, you want to set the guidelines for your talk, establish vocabulary, because that grounds out what you mean so that the minds of your audience don't wander. Because wander time is that fraction of their attention span, which is finite, that you can't use to deposit ideas. Does that make sense? All right. Any questions? And so this presentation is about how to make your presentation not suck, right? And I'll do some things that are bad practices, and then I'll talk about some things that are good practices. Any questions? No? All right. And so this idea of the mind's eye, I remember when I was your age, just, finishing up college, I wasn't a very enthusiastic speaker, had to learn how to do this. But one of the great ways to learn public speaking is to watch videos of people who speak for a living, right? Okay. Now in Delaware, the Biden family is famous and they sometimes call him Crazy Uncle Joe, like that crazy uncle who lets you drive his car in an empty parking lot, even though you're 12 years old, right? So Joe Biden is a very good speaker. The previous president, Trump, was also a very good speaker, and he's a branding expert. Don't let him fool you, right? He's putting on a posture to try to connect with an audience of his choice. So is Joe Biden, right? So was President Obama. So, President Biden has an audience, has many audiences, and these are typically general audiences. Sometimes they're specialized audiences, and he speaks to Congress in the State of the Union in a different way from how he speaks to a general audience. You'll notice he always gives a heartwarming story after a sad story. And the sad story is about some person who struggled in a way, and oh my goodness, this policy helped that person, right? That's on purpose. Not only do they have speech writers, but he also says stuff like, here's the thing, right? Here's the thing. He's trying to be more human. You have to work at being natural. It's kind of weird, sounds counterintuitive, right? He uses personal anecdote and he uses these quips that resonate with an audience that isn't necessarily specialized in public policy, politics, or law. He's a trained lawyer, right? So he's very, very deliberate about the posture he adopts, like putting on a costume in order to resonate with a particular audience. That's really, really important when you're public speaking. Any questions? Yes. I'm sorry? Yes, yes, yes. You have to have what I call professional pauses and these filler words. Because if I use all these like GRE words, you'd be like, what the hell is homeless talking about? Right? Oh boy, he doesn't seem like, he's way over there and I'm way over here and doesn't connect. You have to find the filler, but it has to be authentic. It has to be authentic. People can smell that a mile away if it's not authentic. And so sometimes people use personal anecdote. Sometimes they use slang. Sometimes, if they're not someone who says y'all and you go to a place where people say y'all, don't say y'all. It's not going to be authentic. But you find ways to connect with people on a level that they connect with. And so if you talk about someone's life experience, you study the population. And if you're in a population maybe at different levels of socioeconomic status, you don't talk about going to the country club. You talk about enjoying a beer on the porch. Not that everyone from certain demographics does that, but you have to resonate with your audience. And so that's why knowing your audience is very, very important a priori. And so if you're on a job talk or if you're talking, the first question you should ask your host, who's my audience? Because you want to tune how you deliver a talk to the audience, and you also use body language. So if I said really, really big, right? I had to learn to do that. Really, really small. Or you say it was very, very detailed. Or it was all over the place haphazard. You can use your intonation, you can use your voice, and there's a lot of nonverbal communication that enters into it as well. Okay? But that's something you have to practice and something you have to learn. It doesn't come naturally. Absolutely does not come naturally. Okay. So I remember a piece of advice my PhD advisor gave me, and hopefully it's helpful to you, is that when you think of the attention span of your audience, imagine it as a computer, right? And you're going to write programs for this computer, and your programs consist of all of the words you use and all of the figures you use. And what this program is going to do is to try to cause what's in your mind to come up or appear in the minds of your audience. Now, you don't really know your audience specifically. You can get a sense of your demographic, who's in your audience, but the words you use and the pictures that you display is going to cause something to arise in the minds of your audience. So imagine if Uncle Joe, or I should say President Biden, be more respectful, if President Biden, I've actually met him a couple of times, so yes, he's a decent person. He's a good person. I'll have a lot of stories. In Delaware, it's so small that you really meet your congressional delegation. And because he lives in Delaware, he lands at Dover Air Force Base and you see the motorcade come up and stuff like that. And I lived in Dover. But anyways, so the president, Biden, he might want the audience to conjure up a picture of relaxing after a hard day's work. Now, to him, he might think about the fireplace in his home, and that's not the fireplace in his home. How'd you get that picture, right? He might think of sitting in front of the fire, but for a member of his audience, it might be hanging out on the couch. See, I just used slang. Hanging out on the couch with your dog, right? It's different. What if he said, instead of relaxing after a hard day's work, he said, sitting by the fire? Now, for someone else, that might remind them of a horrific camping accident, right? So you want to be careful about what your intent is. If it's relaxing, it's not sitting by the fire. You're not sitting by the fire. Yes, you are sitting by the fire, but the whole purpose is relaxing after a hard day's work. And so when you use words, you want to try to paint a visual in the mind's eye of your audience. Because if there's a dramatic mismatch, they're not going to engage with you. You're going to lose them. And when you lose your audience, your presentation has failed. Okay. Any questions? No? All right. And so here are some ways to really make your presentation suck. You can have a very long title slide, really small font, and now I can see all of your eyes. You're kind of looking, just scanning it, reading it, not paying attention to anything I have to say, right? So you want to have a lot of white space, short titles. And the title, to let you in on a secret, is really for me. It's not for you. It might be one or two words. And when you practice your presentation, you should be able to practice enough. Just do it again and again and again and again. You take a quick glance at the title and you know exactly what thoughts you want to appear in the minds of your audience. Now, I won't talk about that part yet. So don't do this. Don't have really tiny fonts. Don't have a huge long title. Practice. Your title should be 2 or 3 words, very simple. And that title is really for you. It's not for your audience. Does that make sense? All right. And so, of course, use lots and lots of fortuitous animation with lots of funky colors because, that's going to wow your audience. You want to let the content and the message that you have to be the star of the proverbial show, right? Keep it simple, keep it relevant, and sometimes animation is appropriate, absolutely. If you have automatic animation, that can be sometimes problematic. I like to have what I call stop animation. You advance a slide, there's the next frame. Advance a slide, there's the next frame, because you can control that easily and go back and forth instead of relying on PowerPoint to draw these things and move these things around. Does that make sense? And then, of course, don't use pictures and diagrams. If you really want your presentation to suck, don't use any pictures because, over millions of years, people have not developed all of this visual processing. We are visual beings. About 70–90% of our brain matter is for visual processing. Use that visual processing, all right? Also, if you have pictures, go ahead and change the aspect ratio. The aspect ratio is the proportion of pixels along the x-axis and y-axis. It looks weird, it's distorted. And again, if your pictures look weird and distorted, the mind's eye or the attention span of your audience is not going to be focused on the content. Oh, that's a weird looking squirrel, right? Looks like it's in a fun house in front of some mirrors. And of course, don't be lazy. If you have content that is licensable, or owned by somebody, try as much as possible to actually do license the content. I spend $40 a month on a source online for content that I use in this class, right? Because I want to be able to post it online, and I don't want to get a stop message from YouTube, which I've gotten once in the past. But anyways, and you'll notice here, Karen Burke Photography, right? It's kind of tacky. Acknowledge these people, get their permission, or pay for the content, right? But when you have these big watermarks all over your pictures, it ruins the visual, taking from the mind's eye, or rather the attention span that your audience should be investing in your message. Any questions? Yes. That's a great question. And I've actually butted up against YouTube because you're allowed in fair use to kind of parody things. So I think I'd used, it was Babyface, When Can I See You Again for the probability. And I was interpreting that as the appearance of an event. Sony Music didn't agree, and they have more lawyers than I do. And so you're allowed fair use in academics, and you can also parody, like how Weird Al Yankovic has these parodies of songs. But the problem is, in real terms, is that if you don't have the legal team to defend yourself effectively, they'll always win. And so I don't see it wrong as using music. Some of the royalty-free music collections that you buy, they sound weird, but you have to kind of do that delicate balance between what's legal and what's practical. And if you do something that belongs to Sony Music, believe me, or Disney, they will tell you stop, even though your fair use is correct. You don't have the time, or maybe you do, time or resources to sit in court and prove why you're properly following fair use. So I personally, this is my opinion, think it's fine, but you have to be careful about what you do and how you do, especially if you're going to post it online publicly, like on YouTube or any other sharing platform, because they will come after you. All right. Any other questions? No? All right. And so, of course, the first time you actually look at your slides is when you're giving your presentation. I can't reiterate the value of practicing. What practicing does is it makes you comfortable with the content and the transitions, what works and what doesn't work. And in this day and age, and trust me, I'm one of the worst spellers out there, make sure you check your spelling, right? If you really want your presentations to suck, don't check your spelling. Just let it go. Because what people will do, they'll immediately look at that and gosh, now their attention span has been wasted. And of course, if you're giving a job talk, What this says about you, if you have things that are misspelled, is that you don't have an attention to detail, and you do not want that reputation preceding you when you're trying to get a job someplace. Okay. All right. Any questions? Yes. It's a good presentation, but you want to engage what is interesting to your audience. So having some pictures, very sparse, very specific on what you're trying to do. A good story, good content always beats flashy, right? It's not just flashy slides for the sake of flashy slides. It has to be relevant to that series of thoughts you want to appear in the minds of your audience. Okay. All right. Any other questions? No? All right. And walking around, engaging your audience is also very important. So you see, and some faculty do this, don't turn your back to your audience. You can kind of, after a while, know where your room is, right? Know the geography of your room, so to speak. And so when you turn your back to the audience, humans are social. We want to be engaged, right? And so face your audience. If you need to write something, don't block your content. And you notice when I write, I kind of go like this, right? Because I want you to see what I'm writing while I'm writing it. And then I turn and I talk about it, right? And so you want to make sure you're facing and you're engaging with your audience. And that's something you have to practice. So you know the layout of the room. And I think we're in this room. And it's different if you're not usually on this side to be in front of a room, but just practice it, right? When you practice your slides, get up, stand up, and walk around, okay? Engage your audience. Because if I just kind of spent the whole time like this, and today we're going to talk about decision trees, and here's an ensemble, right? That would not be a very engaging way to present ideas. Okay. Any questions? Yeah. All right. And so going off topic, and yes, I know sometimes I have these quips and anecdotes, is a really bad idea. And so I was going to spend some time, and in the interest of time, I'm going to skip over this. I was going to talk about one of my projects in my research lab that I brought here from Delaware. It involves an autonomous wheelchair. And so I'll just show you some snazzy bits, and I won't talk about them. It's entirely undergrad driven. So at some point, shameless plug, in the future, I'll be recruiting people to work on various aspects of it. It's about maybe 50% done at the moment. Okay. And so, of course, squeeze as much math into your slides as possible, because that's if you really want it to suck and you're trying to show a derivation of some sort, just kind of Xerox the page of a book, just squeeze it all in there. And I know some faculty do this. It doesn't present very well. If I had my choice, I would make chalkboards everywhere, right? Because when, excuse me, you develop an idea in chalk, you give people the opportunity to kind of see where things are going. I try to do that with PowerPoint. I have one step, another step. I highlight the first part, the second part of an equation, tell you what I'm going to do to it, and then show you the next step, right? So I'm trying to kind of do on PowerPoint what is so easy to do and natural to do on a chalkboard modality. But don't kind of vomit all this math all over a page, right? That's how you really, if you really want to make your presentation suck, then go ahead and do that. Okay. And of course, when you jump right into the details, without giving people the high level view, so I'm raising my hand here, nonverbal communication, the high level view of what your system is. This particular diagram is from my robotics course. It doesn't really make sense. It's called DH or Denevit-Hartenberg notation. Now, of course, with this figure, this is a robot arm or a manipulator. At the end, we have the gripper, the hand, and that's called the manipulator endpoint. And you'll notice here, there are some joints at some angle, and each joint has a link length. And so one of the things you try to do is compute a mathematical expression of where this is relative to the base somewhere in the world. And so how you do that is you have some coordinate frames, an XY axis mounted at each joint. So now the position of something in this coordinate frame, you look at the relative relationship between this frame and the next frame, and that tells you where this object is relative to that joint. You do that entire over the whole so-called kinematic chain, and that gives you a mathematical expression for expressing coordinates from the perspective of the hand versus the perspective of the world. And that's exactly what this Denevit-Hartenberg notation does. But before you jump into the details of that, you have to tell people at a high level what you're doing, why you're here. And of course, in the standard robotics course, I would talk about the conventions for the axes and then the different joint types and how you compute this transform for each joint type. Okay, does that make sense? So start high before you go into all the details, because you will lose your audience if you go right into the details at the outset. Of course, knowing your audience. Now, there are different types of audiences. You have a general audience. This is like the general public. They're not data science majors, minors. They might not even be college students, might not have gone to college. With a general audience, what you want to impart to them is a high level understanding of the idea that you're presenting, right? The details require different levels of training. And so this next audience, a technical audience, but they're not technical in your particular area. So maybe you are dealing with, computer scientists or data scientists, but they might not be folks who deal with machine learning or databases, right? And so that's the second level of audience. You give them a high level understanding, but you leave them with relevant details, right? Because they're not in your particular area. Now, this next one is a very technical audience. If you're a machine learning person talking about machine learning and you're in a room full of machine learning researchers or machine learning practitioners, yeah, you can be very, very technical, but you still start with the high level and then you drive down really deep into all those savory details that machine learning people might be interested in. So you always start high, but how low into the details you go has to be tuned appropriately to the audience, because you're going to lose them if they don't have a background in what you're talking about. Does that make sense? So always know the audience, tell a good story, right? A consistent story is what people remember. Again, we're very social beings, humankind. Make it an interesting story, make it a true story, but nonetheless tell a story and let your enthusiasm show through. If you're not excited about what you're talking about, how do you expect other people to make the commitment to commit their attention span to what you have to say, right? So you want to fake it till you make it, so to speak. If it requires drinking some coffee in the morning, whatever, try to be enthusiastic about what you're talking about when you tell that wonderful story that you want your audience to remember. And then you want to connect with people, connect it with something that people might value. And of course, learn how to pause. Now, when I was in grad school, I used to say a lot. Sometimes I let a few slip, but find a way to pause and watch people who speak for a living. They have these ways of what I call professional pausing. And that's going to be very, very different for each of you. It's okay to want to say, oh gosh, brain hiccup, like I do, right? That works for me. But, I just did it. There we go. So where was I? So find a way to pause. Don't have all of these ums littered throughout your talk. It'll kill the message that you're trying to impart to your audience. Does that make sense? Any questions? No? All right. And be your natural self. Be who you are, right? So when you have your presentation, talk about the key points, those pictures in the mind's eye of your audience you want them to walk away with. And when you give your talk, remember, you're not a tape recorder. Your goal is to impart these ideas, to get people to paint these pictures in their mind's eye, not to repeat the precise word that you use when you practice. You could present it 10 times and each time it's going to be different. That's okay. You just want to get the point across. That makes sense? All right, so you design ahead of time the points you want your audience to have, what sequence of thoughts you want them to have in this computer, and you're programming it with your words to cause this sequence of thoughts. But you don't have to be exact, right? You just want to cover the points, not the precise language. And use pictures and diagrams whenever a concept is very complex, because it lessens the burden of what you're talking about. A figure is worth, I'd say, 10,000 words. Okay. And now I've done this before throughout the semester, whether you knew it or not. When I talked about conditional probability, we used this balls and bins, and we said, what if you knew that it came from bin 3? And we walked through it and we had you kind of filter out those balls from bin 3 to show you how this probability of the color changes. And we had 2 attributes. The goal of that is I wanted you to have an algorithmic understanding of how this would proceed, because I knew later on I wanted you to implement or be able to implement a filtering probability or conditional probability. So that's why I did that. It was designed ahead of time deliberately. When we talked about populations and this unknown population distribution, we talked about sampling. There's our population. And I used an example, veterans, families, drug addicted, foster kids for the homeless, because many people at Clark are concerned about the greater community around them. So that example, it wasn't evil. I just used that because I know people care about this. Okay. And so with that, I said, let's sample from the population. So I had these arrows. This is my fortuitous, not so fortuitous animation. And I gave you this idea of pulling people from the population in order to get this data from them. So that's some of letting you experience it, but also grounding it out in something that you care about. And I wanted you specifically to walk away with this idea of you don't get to see the details of these populations, but what you do see is the data that you pull from them, the individuals you pull from them. So that was very deliberately designed. And then we talked about estimators. When we talked about the Baltic Dry Goods Index, we talked about this idea of cargo space as a good predictor of the economy. And we looked at the supply and demand for the available cargo space, and we grounded that in this idea of growing economy versus a shrinking economy. When you have more money, you buy more stuff, the raw materials go in one direction, finished goods come in the other direction. And so with that, the deliberate thing was to try to explain to you this idea of cargo space as a proxy for economic health. It's really hard to talk about, but this particular picture showed you what was happening so that I could explain this complex concept as a pretext for using the Baltic Dry Goods Index and trying to find what the lag time was. Does that make sense? So all of this was deliberate. You design it. And that's what takes so long when you put together a whole semester's worth of stuff. You have to design all of these ideas and the interaction and methods for causing this sequence of thoughts to happen in the mind's eye of your audience. Any questions? So there's no substitute for designing a presentation, and that's during, this is feast times and this is famine times. And then chocolate, right? A lot of people like chocolate, right? In the United States. And so I wanted to teach you something interesting about where chocolate comes from and use that as a way to describe the supply chain. I could have easily started with this, but I wanted you to experience what the various stages are going from raw material to finished goods for cacao to get you your chocolate. Okay. And that was to show you that there are relationships and there are different things that impact to kind of ground out this idea of the supply chain and why you need these cargo transport ships to go between locations around the world. And then this idea of begging your data, right? If you're given a data set, you need to ask it questions. And so I have a cat begging for food, and it's kind of funny, it's kind of warm and cute. And so I was trying to use that as a visual, say you have to keep asking and asking and asking for the things you want from your data if you're given a data set. Okay, so we talked about sampling. Never auto time your presentations. If you want them to really suck, auto time it, because you want to be in charge of when the slides advance. One thing, if you do this professionally or you're going to interview, invest the $30 or so in a clicker, right? I've had this since graduate school, and it just works really well. You can control your presentation, you can walk around and engage your audience, but when you auto time, now you're nervous. Uh-oh, the slide just changed. Always be in charge of the cadence of your slides. Any questions? No? All right. And remember, address the key points. You're not a tape recorder. Your goal is not to regurgitate the specific words you practice. It's to get across some points and some ideas. And these points are the things you want your audience to walk away with at the end of your presentation. Any questions? No? All right. And don't end your presentation abruptly. All right. So remember, I like to have these things. When I wind down, you wind up your audience, you wind them down gracefully, land the plane, so to speak. Okay. And so I had a great time. Thank you for all of your attendance. I hope this was valuable to you. That's really important that you find value beyond just sitting in class and learning something, that you're able to use the material and deal with the messiness of the world. So I applaud you. I know you had to take the course for the major and minor, but thank you very much, and look forward to your submissions. And please don't hesitate to reach out to me if you have any questions about this class or other things. Sorry. I will see you around the department. Take care.